Lesson 2.1, Task 4. Find real solutions of simple quadratic equations. When communicating solutions, it is helpful to reduce solutions to the simplest form possible. When solving quadratic equations, you will often need to simplify a square root. You may need to use the following properties to simplify your solutions. Alright, so these two properties are important. The first one is the product property of a square root. So the square root of a product equals the product of the square roots. So for example, the square root of CD equals the square root of C times the square root of D. And here's another example. The square root of 20 equals the square root of 4 times 5. That allows you to reduce the square root of 4 to 2, and then the square root of 5 stays under the radical form. All right, the quotient property of a square root. The square root of a fraction equals the quotient of the square root of the numerator and of the denominator. So if you have a square root of C over D, that equals the square root of C divided by the square root of D. All right, this is important as most times we have to rationalize the denominator, which is the bottom part. So if we have the square root of 7 over 16, that equals the square root of 7 divided by the square root of 16. Since the square root of 16 equals 4, we can rationalize that, and that becomes now just 4, or a rational number. Alright, so it says, additionally, when the denominator contains an irrational number, you must rationalize the denominator. Multiplying by 1, written as an equivalent fraction, with the same square root as the denominator. Okay, so if you remember, anything divided by itself equals 1. So what they're saying is, if I have 2 divided by the square root of 10, I can multiply by the square root of 10 over the square root of 10, which is just 1. That's just an equivalent form of 1. But I can do that in order to rationalize the denominator. So that becomes 2 times the square root of 10 on top, and then the square root times itself is a perfect square. So now the square root of 100 equals 10, and then I can reduce 2 and 10 to equal 5. Okay, so 2 divided by the square root of 10 is equal to the square root of 10 over 5. These are equivalent fractions, but this one has a rational denominator. So when it says rationalize the denominator, that means don't leave an irrational number in the denominator spot. All right, so let's determine the solutions for the equation for this one here. All right, so it says 3x squared minus 8 equals 0. And you can see they've already worked through this, but it kind of helps just to look at these on your own. So we're going to add 8 first. So we got 3x squared equals 8. Then we're going to divide both sides by 3. So we have x squared equals 8 over 3. Now we're going to take the square root, because the square root undoes something squared. And when we do that, we're going to have a plus or minus square root of 8/3. So now we're going to have x equals plus or minus the square root of 8/3, which we just looked at above, is the same thing as the square root of 8 over the square root of 3. Now, in order to rationalize this, 3 is not a perfect square, so the square root of 3 cannot be simplified as is. But I can multiply by the same thing and make it a perfect square. But I have to do the same thing on top and bottom, because anything divided by itself is 1. And we said up here, if we multiply by 1, we're just kind of manipulating the problem. We're not changing the problem. We're just rewriting it in a different form. So we're going to have x equals plus or minus 8 times 3 is 24. And then a square root squared would just be 3 times 3 or 9, but I know the square root of 9 is just 3. And then I can simplify 24. So I'm going to rewrite 24. I want it's supposed to be plus or minus. All right, so I have 24, I need a perfect square, so 4 is a perfect square. 4 goes into 24 6 times. So I'm going to rewrite this as square root of 4 times square root of 6. And then 4 times 6 is 24. All I did was rewrite this in a different form again. And then x equals plus or minus square root of 4 is 2. Square root of 6 is not a perfect square. And that goes over 3. So you can see they got to the same step we did. But that's how you would look at rationalizing your denominator. All right. All right, let's see what the next question says. All right, why is there a plus or minus in the fourth step where x equals plus or minus square root of 8 over 3? So there is a blank and blank square root for all real numbers. There is a positive and negative square root for all real numbers except the number 0. All right, why should the answer continue to be rewritten after the sixth step where x equals plus or minus the square root of 8 over the square root of 3? And that's because square root of 3 is not rational, so they continue to rewrite this to make the denominator not irrational. So when the denominator is irrational, it has to be continued to be rewritten into a different form. All right, why can you multiply by square root of 3 over square root of 3? Okay, so anything divided by itself equals 1, and multiplying by 1 does not change the value. All right, what property allows you to rewrite plus or minus the square root of 24 over 3? And if you look back to the top here, you can remember that the product property of square roots allows you to do this. So that would be the product property of a square root. All right, so it says, how can you verify your solutions? You can plug them in and see if you can plug them in and check it to see if it works. All right, that's all for task 4. If you have any questions, let me know. Lesson 2.1, task 5. Find imaginary solutions of simple quadratic equations. You can solve simple quadratic equations that do not have real solutions by using imaginary numbers. The steps for solving equation 9x squared plus 15 equals 8 and checking the solutions are shown, but the steps have been scrambled. Select the solution steps so that they appear in the correct order. All right, so the first thing we should have is the equation here. So let's find step 1, which would be the original equation. All right, the next step would be to subtract 15 from both sides. So we should have 9x squared equals negative 7 would be our next step. The next step would be to divide by 9. So x squared equals negative 7 divided by 9. And then the next step would be to take the square root of both sides. So if we take the square root of both sides, we get plus or minus the square root of negative 7 over 9. Then we have to pull out the imaginary unit. So the final step is x equals plus or minus. Oh, and also the square root of 9 equals 3. So pull out the I and reduce the radical when possible. All right, now we have to check the solution. So it says select the solution steps so they appear in the correct order. So we would want to take this solution here and plug it back into the x squared. So let's see what we're given here. So we're going to have 9 times plus or minus square root of 7 over 3i. We're going to square that. So that would be our first step. So that's taking this first step here and simply plugging this in for x. All right, then what are we going to do next? We are going to separate, bring out the I squared here. So we're going to have So the square root of 7 becomes just 7 when you square it, and the square root, or 3 squared, becomes 9, and then they still have the I squared here. So this would be the second step. And then 9 times 7/9 cancels and leaves just 7. So we should have 7I squared plus 15 equals 8. And now we're going to say I squared equals -1. So 7 times -1 is -7 plus 15. Does that equal 8? And -7 plus 15 does equal 8. So 8 equals 8. So by plugging in the answer, we can check it and see that it works. We know that it works when the left side is the same as the right side. So 8 equals 8 proves that our solution is correct. All right, that's all for task 5. If you have any questions, let me know.